In exercise 6, we're given a worksheet that are from a single factor, completely randomized experiment in which sales in thousands per week of agents trained to 3 different training levels, high, medium, and low, are to be compared using, in our case, BlueSky Statistics. The question is, are the average sales different for the different levels of training? Our first challenge in using BlueSky to analyze this data is that the data are not in the correct format. We have 3 different training levels, high, medium, and low, and we have 5 different observations per training level. We want to analyze that with ANOVA. We have to have the table organized in a different way. So to do that, we go to the data sets variables and we choose reshape. We want to use the longer format. So we've done this, and here's what we did. Created a new data set name, called it ANOVA data. The factor levels are training level, and the variable name is sales. We copied over our different levels of training and we executed that dialog box. What BlueSky did with that data is it created a data set that looks like this. So that's the format we need, where we have training levels as a factor and sales as our response. Next, we need to conduct analysis of variance. We go to the analysis menu, we choose means, ANOVA 1 and 2 way. We did that, and here's what our dialog looked like for that. Our target variable is sales, and the factor we're trying to examine is training level. Now further down the page, I chose to plot all comparisons. What ANOVA does is it gives you a statistic that tells you if there is a difference between the different training levels. We don't want to know if there is a difference. We want to know which difference. So we want both. So by which difference, I mean comparing training level 1 to our high to low, high to medium, and medium to low. We want all those comparisons. So we execute the dialog box, and BlueSky does the analysis. So if we look at sales by training level, we see that for training level high, these are just descriptor statistics. The mean sales level is 16.4, low, the mean sales level is 16.2. For medium, the average sales level is 7. And we can look at the median, min, max, standard deviation, other statistics. So we do an ANOVA table, and type 3 sum of squares is the default, and that's fine. And what we see is that there is a significant difference. So that p-value is less than 0.05, indicating some level of training is different from some other level of training. For marginal means, we don't really need this because of the way our data is set up. These are the same as just the means. So marginal means and means are the same. Now we're going to do post hoc tests. So we're going to do pairwise comparison. So if you look at high training versus low training, the mean difference p-value is greater than 0.05. So the difference between high and low levels of training is not significant. Difference between high and medium level training is statistically significant, and the difference between low and medium is also statistically significant. And a plot will really help us understand that better. Here you see pairwise comparison for sales by training level. So this is the estimated sales difference for the different levels. And you can see that low versus medium, there's quite a bit of difference. and high versus medium, there's quite a bit of difference. So low is higher than medium, and high is higher than medium, and high and low are approximately the same sales levels.